I think this question takes a bit of time to get your head around, so the best thing to do is just start coloring some of the numbers and see what happens. Right, let's imagine we color the first number red, and I'm also going to color the second number red. Then what happens if I do this? Well, because the sum of any two different red numbers is a red number, it means that 3 must be red because 2 plus 1 is 3. But then 3 plus 1 is 4, which must be red, and so on. I can also do exactly the same with green. So there's a symmetry to this problem. You could just replace your reds by greens and your greens by reds, and we'll get another arrangement essentially. Okay, so if I have red, red, that's the only thing I can do. What if I have red, green as my other option? Then I've got 1 and 2. So now 3 could be either red or green. So let me make it red. Then I'm going to get 1 plus 3 is equal to 4. So that must be red. 1 plus 4 is 5, and that must be red. Okay, so if I go with that approach, then um, it must be that all the rest are red here. So before I deal with starting with green and get the symmetry, let's have a look at what if I go with red, green, and instead of red, green. Okay, what happens now? Well, 2 plus 3 is 5, so that one has to be green. And then 2 plus 5 is 7, so all the odds necessarily have to be green. Let's take a look. But if I made this one red, then 1 plus 4 would be 5, and that would have to be red, but it's green, so it can't be. So I can kind of use a subtraction approach. 5, because 5 minus 4 is 1. Actually, that doesn't work, does it? I just realized because it's you can't just turn it into a subtraction. It's all about the addition. Right, so basically red plus this one is green, so this one must be green. And once we've got that 4 in there, everything else follows because 4 plus 2 is 6, and we can just keep adding 2 on to get all the evens. So that would work as well. And then, as I said, we can just swap the greens and the reds around. So I'm going to get green, red, green, green, so on. And then green, and all of them being red. And that is it. I've argued that when we have red, red, there's only this, one way of doing it. We could obviously have green, green as well. And then I've looked at the alternative, which is red, green, and I found out there's two different ways that I can do it. If I go with red, green, it has to be this. If I go with, sorry, red, green, red, it has to be this. And if I go with red, green, green, it has to be this. And I just swap them around. So overall, there are necessarily 6 different ways of doing it.